And we're going to do a few different things this fall. I think part of the inspiration for our module this fall were some of the things that the students did this past summer with Henrietta Lacks HeLa cells. So our module this fall is going to focus a lot on cell biology. We're going to talk about cell structure so that the students get an introduction to, that's going to be introduction to cell biology. We're going to talk about two very important processes that happen at the cellular level, mitosis and meiosis. Dr. Mary's going to go over one of her activities that she's going to do for mitosis here in a second. But we'll talk about mitosis, meiosis, we'll talk about Henrietta Lacks HeLa cells. Then we are going to, Dr. Ahmed is going to speak to us about our students this fall about what happens when the cell cycle becomes irregular and it doesn't function as we would expect it to function through all of the different stages. And he's going to talk about cancers. Cancers usually result when the cell cycle does not work the way it's supposed to. Then we'll talk a little bit about human papillomavirus, and then we'll do a dissection. We're going to do two dissections. The section we'll do this fall is on the female reproductive anatomy, and then the spring we'll do the male reproductive anatomy. So without further ado, part of the way we're going to execute our education for our students on cell structure is watching some videos and having them kind of go through educational sheets to kind of explain to us what they understand. So here are the different levels of organization of the human body. So we're going to actually focus on this level, the cellular level, and a little bit of the tissue and organ level, but mostly here at the cellular level. So this is 30 minutes, right? I want to make sure I'm using my time. So give me 1 second. I'm going to have a quick video on mitosis that I want you guys. This is the video that our students are going to
one that lights out?
I don't think so. I think you guys can see fine, right? So, and again, kind of the approach to this is that the students see what we're educating them on, we're speaking about it, and then they actually employ doing an activity that reinforces the educational pieces. This is at the, I believe, electron level, looking at mitosis. But Dr. Mary's activity is going to reinforce the educational points that we want our students to take away from this point. All right, so that's one part. We'll do the same thing for mitosis. I won't go through the videos, but we'll do the same thing for mitosis. And then, Dr. Mary, you want to go over your activity for mitosis?
Sure. Okay, so we're going to have these we talked about this last week, but these cell cycle wheels, and the majority of cells are not in mitosis. They are either resting or they are replicating DNA in the S phase. So the majority, this is just to show them that the majority of the time cells are not undergoing mitosis. And then we'll show them onion root tips to show them that the majority of cells are just resting. But in the onion root tip, there's a lot of cell division going on, so they'll be able to see the different stages of mitosis. So this right here is mitosis. So there's 4 basic phases in prophase, and most of you probably already know this. The chromosomes have been duplicated, and you can start to see them. They just kind of puff up, and you can see this in any microscope. It's kind of cool to watch. It takes like several hours. And then in metaphase, the spindle fibers show up. And so this is metaphase. and the chromosomes line up. And then in anaphase, sorry, I'm not doing this very well. The chromosomes start to go to different poles. And then in telophase, you can start to see 2 nuclei. You can still see the chromosomes, okay? And then the cells divide. So the reason we have the cell cycle wheel is because when Dr. Ahmed starts to talk about cancer, there's very specific ways to stop the cell cycle. If you go out in the sun and your DNA gets damaged, there's like a little police person right here that says, whoa, 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 your DNA is damaged, you should not go on, right? So that's why we kind of really want them, each of them will have one of these. And then each student will have a whiteboard like this, and we have chromosomes, and then they'll have a eraser marker. So we'll take them through the different stages. For instance, like I'm just going to demonstrate metaphase, right? So they'll draw the spindle fibers, and then they can take their chromosomes. I can't do this like this, but, and line them up in the middle. Okay, so obviously these are just 2 duplicated chromosomes, right? With the centromere in the center, the centromere is a little magnet. So then they can just like line them up, right? And then we'll take them through the next phase, which is anaphase, and then they can start separating them. See, it's just kind of more, I mean, it seems almost like preschool, but it kind of like it reinforces to them. And then they can start taking their cell cycle wheel.
I'm passing it around so they can see it.
Yeah, we looked at that last week, and then when we go over the cancer, or we can even have them spin that and then demonstrate what cycle they're on. But then we'll also look at onion root tips under the microscope slide, and they'll be able to identify. These are pretty easy to identify under the microscope. So are there any questions or suggestions? So we just thought, like, instead of just showing it to them, that they could actually, and kids kind of really like,
Sure they do, they like it.
you know, and these are magnets, and then they'll be able to actually demonstrate and take pictures and things like that. So that's what we'll go over for mitosis.
And then, Dr. Matt, you had an activity for cancer biology as well that you wanted the students to walk through, is that correct?
The cell biology.
Yeah. Was there an activity you had for?
This is just looking on activity, yes.
We'll look at HeLa cells under the microscope. We don't have those here, but Dr. Reggie's going to talk, we're going to talk about Henrietta Lacks and the cervix. That's why we're going to show you the dissection so that the students know like actually where the cervix is. But we're going to get Henrietta Lacks cells or slides that they can look at under the microscope. Then we'll do the cell cycle.
Do any of you guys know, how many of you guys know about Henrietta Lacks? 2 people do, okay. So she was an African-American woman that went to hospital in Baltimore, Maryland, and she was discovered later to have cervical cancer, but her cells from her cervix were actually taken and used without her permission to actually study, and those cells became stem cells of sort for discovery of various different other like treatments and things and cancers and things of that nature in science. And then Oprah Winfrey recently did a movie, it's on HBO, about Henrietta Lacks, and she actually talked about her story. But in recent times, an author actually decided to write a book about Henrietta Lacks' story. It's The Immortal Cells of Henrietta Lacks is the name of the book. It's a really good book if you get a chance to read it. But it kind of goes into a bunch of issues about permission and people giving their consent and their rights, and then what kind of financial rewards or compensation that those people should get. Give me 1 second, and I'm actually, since you guys don't know about Henrietta Lacks, the video I was going to show our students, give me 1 second, I will show to you guys. This is a video that I'm going to show to our students. Is there volume?
And Terrell Brown reports on that story, and Terrell is with us. Good morning.
And Nora, good morning to you. Henrietta Lacks cells have been used in more than 74,000 studies for 6 decades, and she and her family were never asked for permission. They contain genetic information about the health of much of her family, and now they're getting a say in how those cells are used. In 1951, Henrietta Lacks came to Johns Hopkins Hospital with cervical cancer. While there, doctors removed some of her tumor cells and discovered they could thrive in a lab. It was something human cells had never done before.
This biopsy taken from Henrietta Lacks produced a cell line that would grow essentially forever and was immediately distributed all over the world.
Named HeLa cells after Lacks, they were used by Jonas Salk to discover the polio vaccine. They also aided research in cancer, AIDS, and diabetes. Dr. Francis Collins, director of the National Institutes of Health, says they've saved millions of lives.
This is everywhere.
But Lacks, poor and uneducated, died in the hospital, and the scientists took the cells without her consent. Her family's fight to control their use was chronicled in the New York Times bestseller, The Immortal Life of Henrietta Lacks, and is now being made into a movie by Oprah Winfrey.
The message for us was that my grandmother is not just a cell, she's a person.
And now 62 years later, the National Institutes of Health is giving them a say. Going forward, all research of the Lacks genome will be approved by a panel with 2 Lacks family members on it.
This is a first time in history for someone to consider the family.
Dr. Collins hopes the family story will trigger a shift in science towards privacy.
Let's say, may I? And let's be sure that we have the chance to explain what that is and give the person a chance to say yes or to say no.
The National Institutes of Health also said that in order to find a cure to some of these complex diseases like cancer, patients need to be comfortable providing the type of information that was taken from Henrietta Lacks. The family won't receive any financial gains from this new agreement.
This is such a fascinating story because it was taken without her consent. The family was not told about it. That obviously violates so many things.
Sorry, just as an aside, just to make sure everybody's together and understands why we're using these cells. So the students this fall are going to look at those cells under a microscope. And then we'll look at cervical cancer cell slides as well under a microscope so that they can see what the tissue actually looks like in a regular state and in a cancerous state. Let me see. And then I will talk about human papillomavirus, which commonly affects the cervix. And then we'll talk a little bit about what that looks like on many different levels, from a histologic level, from a gross level. In some of the slides, I'll talk to them about how you actually test and check for human papillomavirus. And then I'll talk to them about recommendations that medical bodies recommend for cervical cancer screening as an educational piece. Let me see. And then switching gears, the last thing that we're going to do as a group is we're going to do a gross dissection. So we're going to look at the reproductive anatomy of rats, female rats. And then we're going to pair that with an actual virtual dissection. And so here is a virtual dissection. The students can go through and actually learn all the different parts of the anatomy as well from this virtual dissection alongside we'll have in one room a pre-dissected rat where they can see the anatomy, and then they'll actually in another space be able to go through and identify some of this, the anatomy, and we'll work with them on that. Trying to think. I think that's it. Did you guys have any other questions? Oh, what I didn't mention is that like last year, we use some other parts to provide good educational pieces and make things fun for our students. We use Kahoot, and we'll do that again this year. We've already gathered questions. We're still adding more for the students to actually go through and try to commit some of the knowledge that we are imparting to them about cell biology, about cancer biology, and about anatomy. This is the code is just a fun way to engage them and make sure that they are following along and they are learning. So that's it for the physiology module. Are there any other questions, concerns? All right, I think that's it for us.